Hello, and welcome back to Dave's American Flyer Trains. This is a continuation of a series that I've branded Common Hidden Problems, Value Add Finds, and Their Mitigation. That is, things that, if corrected, are going to provide a long-term value and returns in performance and consistency, and use your time probably more wisely. There's not going to be any hype. Everything is going to be based on experience, discovery, and testing. As a video once said, there's no need to look in 7 or 8 or 10 or whatever it was places if your train is having challenges. What this series is designed to do is to aid in focusing down to the cause based upon the symptoms given a solid foundation. That being said, this whole method is based upon the principle of a solid foundation in the core infrastructure of the train, and that is the motor and the reverse unit. The motor being made up, of course, as you know, the brush bracket assembly, the brushes, the spring, the armature, the field. The reverse unit, as you know, being made up of fingers, the finger support boards, the drum, the movement mechanism, and even its support mechanism and its chassis. Get this working, perfected, standalone mode. Get this working, perfected, standalone mode. Connect them together. They should work in harmony together and therefore free you up from having to drill down to this area and looking for the cause of an issue. Nothing's ever perfect, but it's a darn good way, I think, of approaching it. What I'll share in these videos are things that I used to spend in my infancy of working with these American Flyer trains, which to me are just very well sound but simple electromechanical devices. I'd spend an inordinate amount of time in looking at all the wrong places, and I'm going to share one with you in just a moment that I used to spend a lot of time on until I finally understood what really was the root cause. Now, so far in the series, we've looked at 2 items. This will be the third really in the series. The first one really didn't have anything to do, it was more of a tip and a technique rather than a cause and a remedy, and that was axle and wheel removal, not on steam or diesel locomotives, but on tenders and other rolling stock that had, as you know, either sheet metal trucks or sintered iron side frame trucks. And it was a process and a tool to minimize damage, especially to sintered iron side frame trucks. And the tool was nothing more than snap ring pliers, something you can find at most any hardware store in varying sizes and even varying tip arrangements, where as you squeeze the handles, the tip separates rather than closes. I'm going to show you a bonus with that too. It can easily be used to remove the drum from a reverse unit and to put it back in, and it also helps us to do some really fine tuning, especially widening wheel gauge in really small increments to adjust the gauge out or wider. Now, I don't have anything on here to demonstrate it on the table today, but we've also looked at in a previous video the value of adjusting spring tension on power pickup wheels and axles, primarily in tenders. It's not exclusive to them, but it was primarily what it's designed to do. And what my experience had shown, and this was a cause and effect or a cause and a remedy or cause and mitigation, is that I noticed trains were simply underperforming or erratic. And it became one of my go-to places to look, and that is how tightly or what kind of pressure did the spring actually have on the axle. I found that some springs didn't even touch axles. Some springs touched axles but were extremely dirty with grease and oil. Not a good formula, not a perfect formula for a circuit. Others were barely touching, almost just within an eyelash width of touching the axle, which means it was intermittent and could reduce the performance, I thought, of the train. So therefore, I started paying a lot of attention to the pressure on those springs on the axles, regardless of what kind of trackage they went over and how rough it was. Now, the focus in this particular video is a problem that's common, but I think is very well hidden. and that is, and it can be branded as what a colleague of mine termed pilot bounce. What if the pilot wheels or truck on an assembly has no spring? The symptoms are going to be, I believe, reduced performance, maybe some drag, short, derail, inconsistency in operation. And where do we usually look for these? As I once did, it's the track and track accessories. Unknowingly, it was actually bounce in this front truck. And the parts that are going to be discussed or shown can generally be described as the front truck assembly, which sometimes is all of these components together, a guide and truck assembly. Now, this being the truck, the guide is, you might, let's see, a 282. Go back and look at a 282 Pacific. You'll notice that the truck is attached to a guide assembly, which is for the crosshead guides on the locomotive. Sometimes it's referred to as the pilot and front truck assembly, which would be maybe these two components. Of course, these minor components, but the pilot and front truck assembly. If you're going to search for parts on port lines, for example, I would recommend searching on pilot truck or trailing truck. Now, as you know, there's two trucks on a lot of these locomotives that really aren't load bearing, and they have nothing really to do with the performance for the most part. They simply are along for the ride and to make the locomotive look like a full-scale locomotive. And that's the pilot truck or the trailing truck. Then there's one other structure that you'll find on the 350 series, the Royal Blue, the circus trains, the streamlined silver bullet type trains, the 350, 353, 356, 354, 355, whatever that series is. You'll find that the truck, the pilot truck, is attached to not one of these, but to simply a strap that is screwed into the bottom of the boiler body. The different parts that's generally used in this are a shaft or a screw or a stud. In this case, it is a screw. It's a flathead screw. Other times it will just be a smooth shaft or stud. And then there's the cone-shaped spring that you see right here. And I have, by the way, this one, yes, it is shortened a little bit because of the tightness of the distance between these two. And then a washer, which is sometimes used on the small end of the spring to keep it from going through an opening, such as this slot right here on the back of the pilot assembly. And this one appears to be, and you can see these in varying shapes and sizes. I keep a wide range of washers in my parts department. This one appears to be a common space washer that's used in space and thrust washer that's used in steam locomotives. I revisited the factory service manual for every steam locomotive for which I had a factory service manual that American Flyer produced. And I found the spring was listed as a part, as I said previously, in the 350 series. The 350, like the Royal Blue, all the way up to some of the Silver Bullet, the 356, 354 series. I found them on the what I call the 310 series. That is 310, 12, 13, 15, and 16. They're listed there. The 320 series, from 320 all the way up to 326. That's about 6 different locomotive numbers. The 330 series, 332, 35, and 36. And I found the front truck, the spring, with an open end on top. In other words, the spring turned up, in which the open end of the cone was toward the top, up against this structure. A washer and a screw and a stud. That being the components of this if you go looking for parts.